My name is Zach Kelly. I'm an R&D scientist with Heraeus, and I'm here today to talk to you about printable thick film heaters. I'll be focusing mostly on the essentials for design, but also touch upon material selection and printing. Figure out which hand is best here. All right, so first I'll go through a quick introduction about the applications as well as material selection and the available technologies. Then I'll start going into the fundamentals, Joule heating, temperature coefficients of resistance, material properties versus design properties, and then the characterization methods that we use in the lab to determine how these materials perform. And then finally, we'll kind of go into some case studies, design principles, performance for first heaters on steel, which is a little bit more straightforward, and then talk about heaters for polymers, specifically these PTC materials that have a near exponential positive TCR response. All right. So in terms of the application advantages for design, form factors and design flexibility. So for things like limited spaces, miniaturization, thin substrates, large, small areas, different shaped surfaces, this allows you to design for, as well as precision and uniformity. In terms of performance, what we kind of look for is fast response times, power handling in terms of high watt density. This is more for those high temperature applications. It's a little bit different for the low temperature polymer applications. And then also high reliability, checking that through thermal cycling, thermal shock, humidity, environmental stability, and chemical stability. And then the different material systems that we have, basically they kind of come in packages with the conductor, resistor, insulator, and dielectric layers. Operating temperatures up to 700 C, as well as low operating temperatures as well, and a number of different substrates that are commonly used for these applications. So kind of moving on here, thinking about where we see the applications. So, the different pastes are compatible for different things, and when you're building a circuit on these various substrates, you can use these different systems. So again, comprised of conductors, resistors, and insulating materials. Where we kind of see a lot of applications is in automotive, but also growing kind of fields are medical, consumer, industrial, new energy or alternative energy, as well as aerospace. So looking mostly at automotive here, there's different high voltage and low voltage applications. So for the high voltage heaters, we're thinking about cabin heating, especially for EVs, right? They don't have the combustion engine that can produce the heat anymore, so the heat needs to come from somewhere else. As well as battery heating, which to optimize battery performance and kind of increase mileage, that's becoming a more and more critical field. And then in terms of the low voltage heaters, again, depending on the battery system, you can use some battery heating, seat and steering heating, defrosting ADS and side mirrors. So we see a lot of applications there, and you can see in different parts of the car where these applications can potentially go. All right. And then this is a nice graph where we have our, show the versatility of the different thick films and by substrate. So here we have PET, glass, aluminum, stainless steel, alumina, and aluminum nitride. And as you go up in power density, you basically can use these different systems for these different applications. So, and then depending on your target operating temperature, you can kind of select from these systems that we have available. All right, so kind of moving on to the heater technology. So there's basically four that Heraeus kind of offers, essentially. So the two that I'll be focusing on today are heaters on steel as well as heaters on polymer. So for heaters on steel, this is our most significant market share and growth, newest applications for high voltage EVs, and consumer applications including appliances, water purification, tea kettles, coffee kettles, and then working towards NPM materials for commercial applications. For heaters on aluminum, this is a newer field for us. There's advantages over heaters on steel in terms of high voltage automotive applications, efficiency, thermal transfer, and cost. Still developing and working with customer validation here. And then heaters on ceramic, wide range of applications, offering temperatures. These tend to be some of the higher temperature applications as well. Fits better, best with our traditional thick film materials. These are the high fire